So LANCE is our flagship experimental facility. It's about an almost 50-year-old accelerator facility. It came online in 1972 as the Los Alamos Meson Physics Facility. At the time, it was at the cutting edge of nuclear physics research. Around 2000, sort of nuclear physics had moved past what we could do here, and so we repurposed it as LANCE, the Los Alamos Neutron Science Center. And so we still use that same accelerator infrastructure, but now we're delivering protons and neutrons to do a whole range of scientific applications.
So I love working with neutrons and getting to work at a neutron facility like LANCE because neutrons are just an absolutely fantastic tool for probing all sorts of different physical systems, from the fundamental to the very applied. Neutrons are a composite particle. Inside of them they have lots of quarks and gluons, and so you can actually peek inside of a neutron and see the exact same physics that occurred during the Big Bang.
So one of the really neat things about LANCE is that we use the protons we generate and accelerate to do a whole variety of things. And there are 3 experimental facilities we have where we use those protons directly. The rest, we actually use those protons to make neutrons. So we will slam those protons into a heavy nucleus and spit out a bunch of neutrons. And then we use those neutrons to do things. One of our facilities, we study the neutrons themselves. That's our ultra-cold neutron facility, where we'll take those neutrons, we'll cool them down by 13 orders of magnitude in energy, and then we will study how long they live and how they interact with matter.
We make these ultra-cold neutrons and use them to run experiments in our experimental facility. We have multiple experiments, and each one of them is doing something to expand our knowledge of the particle interactions.
We start with the protons from the LANCE accelerator, and those generate neutrons in a spallation reaction on a tungsten target. Then we have neutrons. The neutrons have a lot of energy. We work with these extremely low energy neutrons. They're hundreds of nanoelectron volts, so very low energies. And to produce them, we thermalize them in a moderator. Our moderator is solid deuterium.
So one of the experiments that we work on right now, it's called EDM experiment. EDM stands for electric dipole moment. This basically measures separation of positive and negative charges inside neutrons. Standard model predicts a value, but it's very small. So if you see anything that's bigger than the standard model, that's a great a signature of new theory beyond the standard model.
We can also use the neutrons to probe other things. And so instead of studying the neutrons, we're using the neutrons as a probe. We do that in a material science sense, where we use it to probe the structure of molecules and crystals. Neutrons are neat because unlike X-rays or photons, and unlike charged particles, they interact very differently with matter. And so you can probe things and see things with neutrons you just can't see otherwise.
So neutrons are actually an incredible tool to be able to use to characterize materials because unlike charged particles like protons and electrons, they don't get hung up in the electron cloud on atoms. So we're actually able to probe the nuclear structure of a material itself. And considering that a material's crystal lattice is the arrangement of the ions inside of that lattice, neutrons allow us to actually determine what the structure of a material is. In addition, they don't have electrical charge, but they do have a magnetic dipole moment, which allows us to also get information about the spin distributions and the magnetic properties of material. And this is very important for us to be able to take precision characterization measurements of materials. So for example, with molten salts, they want to use those in reactors, and in order to be able to safely use them in reactors, we have to know their properties very, very well.
Los Alamos was one of the birthplaces of big science, right? This is the place where we got started, bringing together a large and diverse team to solve problems that none of them could solve individually. And in many ways, that's still our competitive advantage. If you have a really hard problem that needs a multidisciplinary approach, this is a great place to do it because we have world experts on computing and engineering and part fabrication and the fundamental science, and you can bring them all together to solve some problem and move on.
I think that engineering is a critical component to all of the mission at Los Alamos National Laboratory. The experiment that we're working on here at LANL to measure the neutron's electric dipole moment, the NEDM, is a very good example of just how challenging the engineering aspects can be.
One of the most amazing things about working in a lab this size is that if you have any kind of question, no matter how esoteric, it's very likely that one of the world experts on this weird niche little topic is probably down the hall somewhere or down the road. So the coolest thing is you almost never get stuck on a problem because there are so many people around you to help you out on something.
I'm just excited about the next 50 years of LANCE. LANCE will turn 50 in in 2022, and we plan to keep running it for another 50 years. We're putting some major investments into the accelerator to make it more reliable and more functional, and then into our experiments. And we're looking forward to helping to lead science in a bunch of areas for the next 50 years.